All right, guys. I want to take a look at this worksheet here. Case I'm not here when we get a chance to go over the second part of this. So we did the first page of this last class, right? Sketched the velocity time graphs, and then we also sketched the position time graphs to match along with that. So we should have this part done already. We get object moving away from the origin, right? You get a positive line right there on a position graph. Looks like a flat line on a velocity graph. Object standing still, position graph is just a horizontal line anywhere on the axis. Velocity graph is a straight line. It's got to be at zero because standing still obviously has zero velocity. Moving towards the origin at a steady speed and then standing still, right? We should have downward line for moving towards the origin and then flat line for standing still. We get a negative slope for moving towards the origin and then a flat line for standing still. So that matches that. And then our last one here, we have an object moving away from the origin and then reverses direction and moves back towards the origin. So we have away from the origin, towards the origin. If we match that to a velocity graph, we get positive velocity and then negative velocity for moving away from the origin and then towards the origin. So that's what we worked on yesterday, kind of setting up getting our position graphs and our velocity graphs matched up. What we want to look at today is a little bit more specifics, right? So we kind of know, we know based on our first problem that this graph, right, a diagonal position versus time graph should match with a positive velocity, right, straight across. But we can actually get a little bit more specific with that if we look at some of the numbers here, and we can actually figure out how or where, I guess, to draw that line, right? Does it go at the 2? Does it go at the 1? We know it has to be above 0. Does it go at the 0.5? Does it go at 1.5? Right? Where does that line go? We can actually figure that out if we look at the numbers a little bit more closely. So if we check out this problem here, and let's go up to draw, and I'll get a pen out. We know this is positive, right? We know that's constant velocity. And we know the general shape over here. If I just draw an example, right, we know this is going to be a flat line. But what we want to figure out right now is where does that line go? So what we're going to do is look at the slope of this graph, actually calculate the slope, and we can figure out where we're supposed to draw this line. So if we recall, right, I'm going to do this over on this side so I got a little bit more space. The equation for slope is rise divided by run, right? Rise meaning up and down, run meaning side to side. So from the start, right, how high does this line go and then how far does it go? So if we look at this, right, our rise, we go from 0 up to 4. That's a rise of 4. If we look at our run, we go from 0 to 4, that's a run of 4 as well. So if we look at our slope equation, we get 4 for the rise, right? That comes from here, divided by 4 for the run. 4 divided by 4 is 1. So we can actually figure out now where to draw our straight line for velocity. It actually goes on the 1 right here. So we can trace that across. Our velocity is 1 the whole time, right? That graph doesn't change. It's 1, up 1 over 1, up 1 over 1, up 1 over 1. We could do it for all the little segments right there, but rise over run, if we look at the total, 4 over 4 gives us 1. So now, instead of just looking at this conceptually and knowing that this position graph, this diagonal, which means positive constant velocity, right, increasing position, right, instead of just knowing that it's going to be like a flat graph, flat line, we now also know exactly where to put that line, right? If we can calculate the slope, we can figure out that that line belongs on the 1 right there. All right, and we're going to do the same thing with all this stuff, right? So we have 2 more examples here. Next one's a little bit trickier because we're going to have to break it into a couple parts, right? The motion changes at 1 second here. So we're going to have to figure out, okay, what is the slope for this part? And then what is the slope for this part? But we're doing the same thing. Slope is rise over run. So if I do the orange part first, slope equals rise over run. If I look at the rise, which goes from 0 up to 2, that's a rise of 2. If I look at the run, we go from 0 to 1. So rise was 2. Over run was 1. We get 2 over 1. 2 divided by 1 is 2. So our slope from 0 seconds to 1 second, right? This only happens in this first little bit. The slope is 2. So I'm going to come over here and I'm going to draw in my line at 2. Right? Flat line at 2. It's 2 seconds for the velocity is 2 for that first second. Then I got to do the same thing with my purple line, right? So I'm going to calculate the slope again. Slope is rise over run. Put a little line here so we know we're doing a different calculation. And we do the same thing, rise and run. So the rise, we go from 2 to 4, that's 1, 2. Run, we go from 1, 2, 3, 4. So our rise was 2, our run was 4. We get 2 over 4. Now we got a fraction. 2 divided by 4 is a half, or 0.5. So our line, after it does the 2 for the first second, now it's got to drop all the way down to 0.5, and it's 0.5 for the rest of the time. So again, we probably knew that a straight horizontal line or a straight diagonal line leads to a flat line on a velocity graph, right? We saw that in our very first question, right? Diagonal line leads to a flat line above the axis. We see it here again. Diagonal line leads to a flat line above the axis. Here we see it again. Diagonal line leads to a flat line above the axis. But we're doing it a little bit more specific now. We can actually calculate the slope, right? Rise over run. 4 over 4 gives us 1. We can put that in there. 2 over 1 gives us 2. So we start with 2. 2 over 4 gives us a half. So we have to drop down to a half. And we can see here another thing that we talked about, right? The steeper the line is, the faster the object's going. So the object here was going 2 meters per second. It was going pretty fast. We can see that steep line. And then over here, when it switches to being a shallower line, it's not going as fast. So the velocity goes down. It switches to 0.5 for the rest of the time there. So we're seeing a couple more things in action for that second one. All right, and then the third one, we get a same kind of situation as our last one here, right? Object moves away from the origin and then reverses direction and moves back. Right, so away from the origin and then moves back. And we can, I'll do the first part in purple here. Again, we're going to have two different parts because we have that first line and then we have the second line. But we're going to do the same thing, right? We know that a diagonal upward line leads to a flat line on a velocity graph is a flat line above the axis. So I'm going to do the same thing. Slope equals rise divided by run, right? And I can go rise and run. I'll count the boxes, 1, 2, 1, 2. So rise was 2, run was 2. Slope is going to equal 2 divided by 2. 2 divided by 2 gives us 1. So how long does that motion last for? That purple line goes from 0 seconds to 2 seconds. So from 0 seconds to 2 seconds, our line is going to be at the 1. Then we got to do a second calculation to calculate the slope of the orange line. Now this is our first one. Again, rise over run, where we're going downwards, and we know from problem 3 and 4 that a downward line means a line under the axis, right? Downward is a straight line under the axis. So we know that we're going to be in the negatives down here, but let's calculate what it is. So rise over run. This one we go from 4 down to 0. So because we're going down, instead of getting a positive number, we're going to get a -4 because we went down 4. So we're going to get a -4, and then run, we go from 2 to 4. That's still a +2. So we're going to get -4 divided by 2. -4 divided by 2 gives us -2. So we know from 2 seconds to 4 seconds down here, we're going to drop all the way down to -2 for 2 seconds to 4 seconds. All right, we can see slower because the line's shallower, faster because the line's steeper, but this one's going backwards, right? It's going in the negative direction. So we drop down to the negative. So we had a +1 switching to a -2, and we can see that here, +1 switching to -2. All right, so there is the completion of that worksheet. I left extras for the sub in case you guys are missing that. And I think that's it. I'm gonna stop that there as soon as I can find the stop button.